Okay, good morning. I'm going to make a quick video here to go over the homework, which was 160 to 163, the odd numbers. Okay, what is the sum of the oxidation numbers in the compound CO2? Okay, so if it's CO2, that means all of this has to equal 0 since it's a molecule, and molecules have a 0 net charge. So here's what I do. Start with carbon. Well, I don't have to actually do anything, do I? Because the sum of the oxidation numbers here, since there's no charge here, is going to be 0. So number 1 is 1. Okay? Any molecule is going to have 0 for its sum of the oxidation numbers. Number 3, what is the oxidation number of PT and K2PtCl6? Okay, split that one up. So I've got K2 and then PtCl6. Well, potassium is in group 1, so there are 2 of those, and I know that any thing in group 1 is a positive 1. So that's a positive 2 total for that one. PT, there's 1 of them, and I don't know what it is, and that's what I'm looking for. And then chlorine, there are 6 of them. Chlorines are, for the most part, going to be -1. So that's -6. And this is a molecule, so the total has to be 0. So what number has to go here in order for this to equal 0? +2 and a -6 is a -4. -4 plus a +4 gives me 0. So the answer for 3 should be 4. Number 5. What is the oxidation number of sulfur in H2SO4? So, there are 2 approaches that I could have here. I could say, I could figure out the whole thing. There are 2 hydrogens, there's 1 sulfur, there's 4 oxygens. Hydrogen is +1. Sulfur I'm looking for, and oxygen is almost always -2. This is a molecule, and therefore it has a total of 0. So in this case, this has to be 6. Okay, so my answer for number 5 is 3. Now the other way I could have done that was, I know from table E that SO4 is a 2- polyatomic ion. So I could have done the same thing. 1 times, I don't know, 4 times -2, -8. But my total this time would be -2. So either way, I get 6 as an answer. Okay? So that's 5. All right, we've got to move this around to get number 7. This is going to be a little awkward, so bear with me. That wasn't too bad. All right, 7. What is the oxidation number of manganese and KMnO4? Okay, same thing. I've got potassium, manganese, and oxygen. 1, 1, 4. Potassium's in group 1, so that's going to be a +1. Manganese I'm looking for. Oxygen is almost always -2. What's my total have to be here? Well, this is a particle that is a compound. It's not an ion, it's a compound. So the total here is going to be 0. So -8 and +7 is a -7, and in order to make it 0, we have to have +7. So the answer here is 4 for number 7. Number 9, oxygen will have a positive oxidation number when combined with, well, that's one of the rules, and I believe, and you probably won't see this, the answer here is going to be fluorine, but I wouldn't worry about that one too much. Okay? Sorry, it's shifting around. Number 11. Number 11. Just a second. See how it works. Sorry. There. Which equation best represents an oxidation reduction reaction? Okay, so in general, you're going to have a substance on the reactant side that is not combined on the product side. The other rule here is if you've got an acid and a base, a neutralization reaction, this is not a redox reaction. So one is out. Here's chlorine combined with hydrogen, and then over here it's by itself. So you know that the oxidation state here is going to be 0. In here it's going to be -1 or something other than 0. So that's your answer. If you find something that is by itself on one half of the other, and then it's combined with something, then that's going to be redox. 13. Same type of question. Which balanced reaction equation represents an oxidation reduction? So what do we have here? Do we have anything by itself that ends up? Now this is called a double displacement. Okay, so this is not one. What else do we have here? Okay, so we have something by itself, number 2, iron by itself, and then iron combined. Here it's a 0, here it's something other than 0. So your answer for 13 is 2 again. Okay? Number 11, the answer was 2. 15. Which statement correctly describes a redox reaction? Okay, in a redox reaction, they always happen at the same time. When the electrons are given up, they're taken up by the other thing. So 15 is going to be 1. They always happen at the same time. Number 17. All redox reactions involve they have to have both a gain and a loss of electrons. And we know that because, that's 17, we know that because the law of conservation of energy. You can't just lose electrons. They have to go somewhere right away. All right, number 19, just some more adjusting. All right, let's see what that looks like. All right, 19. What occurs during the reaction below? Well, let's take a look. I've got chlorine over here that's a 0 by itself. And then chlorine over here is a -1. This is a +1. I know oxygen is almost always -2, so this one's a +1. Chlorine, when it's combined with something, is a -1. So 2 times -1 is a -2, so this has to be a +2. Oxygen is a -2 for the most part, so that's -4, so that's a +4. So hydrogen goes from 1 to 1, actually it doesn't change at all. Chlorine goes from -1 to 0, so its oxidation number actually goes up. So this is getting oxidized. So in 19, chlorine is oxidized. Manganese is a positive 4, and then it goes to a positive 2. When the oxidation number goes down, it gets reduced. So manganese is reduced. Let's see where our answer is here. The manganese is reduced and its oxidation number changes from positive 4 to positive 2. Well, there's my answer. 19 is 1. Okay? Remember, when the oxidation number goes down, that's the same thing as the oxidation number getting reduced. That's where that name comes from. 21. When a substance is oxidized, okay, remember your Leo Gur, right? Leo Gur or oil rig, oxidized, losing electrons. Well, that's not one of my answers. So, if something is oxidized, it is the reducing agent. And when something is reduced, it is the oxidizing agent. Since they're telling you it's oxidized, it acts as a reducing agent. So 21 is 4. All right, almost done here. 23. Move this up a little bit. Consider the following equation. Which species is oxidized? Okay, let's look. Well, oxidation means that the oxidation number is actually going to go up, right? So here is iron at 2+, and iron goes to 3+. So that means this gets oxidized, Fe2+. So 23 is 3. Hydrogen is a +1, it stays a +1. Water, they're not going to show you a molecule that's getting oxidized. They're only going to show you one thing, because the whole thing doesn't gain or lose electrons. It's got to be one part of it. All right, 25. Consider the following reaction. Which one undergoes reduction? Now, reduction means that the oxidation number gets reduced. So here it's a 0, and here it's a positive 2. So this is actually going up. For 10, it goes from positive 4 to positive 2. This gets reduced. So SN4+ gets reduced. So 25 is 2. 27. Consider the following equation. Which is the reducing agent? Well, you have to remember that the reducing agent is the thing that gets oxidized. So it's a fancy way of asking what's getting oxidized. Also remember that when something gets oxidized, its oxidation number goes up. So lead goes from 0 to 2+. Well, there's my answer. This is the thing. 27 is 3. This is the thing that gets oxidized. 29. In this reaction, the oxidizing agent is what? Well, oxidizing agent is the thing that gets reduced. So it's the opposite. So what's getting reduced here? I've got oxygen at a 0 on this side, and it's -2 here. It's also -2 here. So in either case, oxygen is going from 0 to -2. Its oxidation number is going down or getting reduced. So 29 is 1. The last one is 31. In a redox reaction, the reducing agent will, if it's a reducing agent, that means it gets oxidized. If it's oxidized, that means it has lost electrons, like Leo, yeah? Losing electrons. So the reducing agent will lose electrons and be oxidized. 2. 31 is 2. All right. Hopefully you followed along on that. And we'll continue.